Your wood mulch is not protecting your soil. It is starving your plants by locking up essential carbon in a slow decomposition cycle that ties up nitrogen for years before releasing anything useful to the root zone. Stop waiting for wood to break down and switch to a living white clover carpet instead. This simple swap triggers an immediate biological shift, pumping atmospheric nitrogen directly into the rhizosphere through one of the most efficient nitrogen-fixing systems in the plant kingdom, and it costs almost nothing to establish. Wood chips carry a carbon-to-nitrogen ratio between 400:1 and 500:1. When soil microbes begin breaking down this high-carbon material, they consume nitrogen from the surrounding soil to fuel their own metabolism, a process called nitrogen immobilization that depletes the very nutrient your heavy feeders need most during active growth. Beneath a thick static wood mulch layer, soil temperatures fluctuate, moisture distribution becomes uneven, and the biological diversity of the upper soil profile declines as microbial communities adapt to processing carbon rather than cycling the full spectrum of plant-available nutrients. The mulch surface looks productive, but the biology underneath is running on a limited, carbon-dominated fuel source that benefits the decomposer community far more than the plants growing above it. White clover, Trifolium repens, forms a symbiotic relationship with Rhizobia leguminosarum bacteria that colonize the plant's root nodules and convert atmospheric nitrogen gas into ammonium, the form of nitrogen plant roots absorb directly. This biological nitrogen fixation delivers between 100 and 200 kilograms of nitrogen per hectare per year under productive growing conditions, a continuous, free nitrogen input that no static mulch material can replicate. The clover functions as a biological solar panel, capturing energy from sunlight and directing it into a root system that simultaneously feeds the soil food web through nitrogen-rich root exudates and physically structures the upper soil profile through dense, fibrous root growth. Unlike synthetic nitrogen applications that spike availability and then leach below the root zone, clover fixed nitrogen enters the soil gradually through root turnover and decomposition, maintaining consistent availability across the growing season. Living clover roots release a constant stream of root exudates, sugars, amino acids, and organic acids that feed the microbial community in the rhizosphere at a rate no decaying mulch layer matches. This continuous carbon input sustains bacterial and fungal populations that process and cycle nutrients for every plant in the surrounding bed, not just the clover itself. The root channels created by clover's dense fibrous network also improve soil porosity, allowing water and oxygen to penetrate deeper into the soil profile and creating the aerobic conditions that support the full spectrum of beneficial soil biology. A bed underplanted with established white clover carries measurably higher microbial respiration rates than the same bed under wood mulch. The biology runs faster, cycles nutrients faster, and delivers more to plant roots per unit of time. Managing white clover as a living mulch between crop rows requires one simple intervention: regular height management. Allow clover to reach 15 to 20 centimeters, then cut or crimp the top growth and leave it in place as a surface green manure layer. This chop and drop approach releases a concentrated flush of nitrogen-rich organic matter that soil microbes process within days, delivering a targeted nutrient pulse to the surrounding root zone at precisely the moment the cut material contacts the soil surface. Repeat this cycle every 3 to 4 weeks during peak clover growth. Keep clover trimmed below the canopy height of your main crops to prevent shading. Established tomatoes, peppers, and brassicas tolerate clover understory without competition when height is managed at or below 10 centimeters during the main crop's fruiting period. A bed managed with white clover as a permanent living mulch builds measurably better soil structure across successive seasons compared to wood-mulched beds. The dense root network increases water retention capacity, reduces surface crusting, and creates a stable aggregate structure that supports deeper root penetration from the crops growing above. Clover can be terminated at the end of the season by cutting and incorporating the top growth or simply allowing winter frost to kill the above-ground biomass while the root nodules release their stored nitrogen directly into the soil profile. A final fertility deposit that feeds the following spring's planting without any additional input. Subscribe to Natural Crops and AMP Soil Hub for more evidence-based soil strategies that build living fertility from the ground up.